Hi, welcome to the mathcenter.com. In this video, we are going to be looking at a STEP exam question. STEP 2018. This is the exam that students hoping to enter math-related programs in Oxford and Cambridge take. Again, STEP 2018. This is question number 12 in the statistics portion of the exam. Let's read the question. Before that, let me make a few remarks. The things that you need to handle this question. Number one, you will need to catch on to the idea of a tree diagram. Okay. Two, we need the idea that the expected value of x, will be xpx. Again, the expected value of a random variable x will be xpx. This is summation, first moments. And then we have the expected value of x squared will be summation x squared px. We need that. And then we have the formula for variance, which will be expected value of x squared minus expected value of x whole thing squared. We need this. And then what else do we need? It may be helpful for you to know that if x is a binomial random variable, then the expected value of x is np and the variance of x is npq, where q is 1 minus p. Okay? Again, if x is a binomial random variable with the parameters n and p, the mean value will be np, the expected value of x, and the variance is np times 1 minus p. Okay, these are the only things that we need to solve this problem. Now, as you get to the later parts of the question, there will be some intensive algebra, but let's see how we can keep that to a minimum. A bag contains 3 coins. Okay, 1, 2, and 3. The probabilities of their showing hits when tossed are P1, P2, and P3. Okay. A coin is taken at random. This is part 1, You take a coin at random from the bag and toss. So when you pick a coin at random, never mind, let's finish the questions first. What is the probability that it shows a head? Now, that's what I meant by a tree diagram. First, we need to pick the coin, 1, 2, or 3. So the probabilities here will be 1 over 3, 1 over 3, 1 over 3. And then we have a head, head, and head. Okay. Now I did not plug in the tail. If you want, you can. The other branch of it, you want, you can. That's not important for us. So coin number 1, it's P1. Coin number 2 is P2. And coin number 3, it is P3, the probability of getting heads respectively. So now you're asked to find the probability that it is showing a head. So we can write probability of a head will be probability of 1 and head plus probability of 2 and head plus probability of 3 and head. So that will be 1/3 times P1 plus 1/3 times P2 plus 1/3 times P3, and you'll get 1/3 P1 plus P2 plus P3. Okay, and we are done. So that's what you will see here. Okay, that's what you'll see here. Okay. And we are done with that part. So let's come back to part 2. Part 2, a coin is taken at random from the bag, the previous bag, and tossed. And what happens is the coin is returned. Very important, The coin is returned to the bag, and again a coin is taken at random from the bag and tossed. That return thing implies independence, Okay, n1 is a random variable whose value is the number of heads shown on the 2 tosses. So n1 is the number of heads shown on the 2 tosses. You're asked to find the expected value of n1 in terms of p, where P is this thing here, 1/3 of P1 plus P2 plus P3, and then you ask to find the variance of N1. Okay. Now, remember from your binomial distribution days, before I talk about a more detailed solution, right? From our binomial distribution days, if X is a random variable representing a number of successes in a fixed number of trials, again, yeah, X is a random variable representing the number of successes in a fixed number of trials, this one here will be binomial NP, the binomial random variable, yeah? Each trial has 2 outcomes, so number of trials is N, the probability of success is P, the expected value of X here is NP, and the variance of X here is NPQ, and you know that Q is 1 minus P. Now here we are looking at, let's talk about the shortcut first, yeah? We are looking at N equals to 2. Why? We are looking at 2 trials, yeah? 2 independent trials. And the success, okay, of getting a hit, okay, this is getting a hit on each trial, okay, probably getting a hit on each trial is 2. So what is the expected number of hits you can get, yeah? So the expected value of X here will be just NP, and you're done with 2P. Now this is one way of looking at it, because N1 here is the number of hits, so we're looking for the expected number of hits, okay? The expected number of hits, okay, expected number of hits. We're looking for the expected number of hits in 2 tosses, okay? Expected number of hits in 2 tosses. So we can think of it as a binomial distribution problem and then get the answer down straight away as 2P. And the variance will be, the variance of here, if I just write it as X, the variance will be NPQ, it will be 2P 1 minus P, okay? And we are done. Now, if that didn't strike you, okay, if that didn't strike you, then what we'll have to do is we'll have to think of writing down the expected value as X times PX and sum it up. So that's what I've done here, okay? Remember what N1 is, yeah? N1 is the number of hits on the 2 tosses. So N1 can be 0, 1, or 2, yeah? What is 0? 0 means no hits, yeah? No hits means both the tosses you have tails. So the probability of getting a tail on one toss is 1 minus P. So you'll take 1 minus P times 1 minus P. So the probability of no hits will be 1 minus P squared. The probability of getting 2 hits will be P times P, which will be P squared. Now, the probability of getting 1 hit will be just taking total probability must be equals to 1. So it will be 1 minus P squared minus 1 minus P whole thing squared. That's what you see here, yeah? Total probability is 1. So the probability of getting N equals to 1, okay, and 1 equals to 1 really, will be equals to 1 minus this minus this. And when you clean up the algebra here, okay, when you clean up the algebra here, you'll get 2P times 1 minus P. Now, what is expected value? Expected value is X PX. Now, we don't have to worry about 0 here because 0 times anything is 0. So, we'll just take expected value of N1 as equals to 1 times, what's the probability of N1? Good. 2P times 1 minus P and plus 2 times probability N equals 2 is P squared. So that's what you see here, 1 times 2P times 1 minus P, okay, and then plus 2 times P squared. If you clean up the algebra here, you'll get 2p, and we are done. Now to find the variance, we have to use, let me write it here, the variance of n1 will be the expected value of n1 squared minus the expected value of n1 whole thing squared. So this one here will be using the idea x squared px. That's what you see here. Okay, so the first value of n1 which is possible is 1, so 1 squared is 1 times the probability will be 2p times 1 minus p. The second value of n1 is 2 squared is 4, and the probability of 2 is n1 equals to 2 is p squared. You clean this up and you will get 2p squared plus 2p. Now the variance will be the expected value of n1 squared, which is 2p squared plus 2p, minus the expected value of n1 whole thing squared. Clean this up. Okay, this is 2p squared and this is 4p squared. So you'll have minus 2p squared. And I have 2p minus 2p squared, and you'll get your final answer as 2p times 1 minus p. That's it, yeah. So like I said, you could have seen this from a binomial distribution point of view, like I explained here. And if you didn't see that, you have to go through quite a bit of work here, which is not too bad really. Okay, so please give this video a like and share as much as you can. Follow me on Facebook and YouTube, and I hope you enjoyed this video. Thank you.